In optical property, which I just repeat, in optical property we studied about light microscope where we identify the structure and shape. Next, electron microscope, same structure and shape. Then turbidity, what you are going to estimate? Concentration. Now in kinetic property we have Brownian movement. Listen to me carefully. Any particle which is under 5 microns, any particle which is under 5 microns will come under the influence of or will show Brownian movement. Any particle under 5 microns will show Brownian movement. Okay, it will show the Brownian movement. Why there is Brownian movement? You can ask, sir, what is the reason Brownian movement is there? The reason for Brownian movement is, anybody, what is the reason? Why they are colliding? Okay. Same charge, they are going away. Okay, next. How they are moving? We have, wait. We call it as thermal movement. What happens there is, whatever heat is there is absorbed by your particle. After absorbing heat, it will start moving. When it is moving, when they have same charge, they will repel. When they are moving, if they have same charge, they will repel to each other. So, sign of Brownian movement. Your colloid having Brownian movement is a good or bad? Why? Very good. In Brownian movement only they are individual. I want the particle to be individual in case of colloids. Colloids should be single, not paired. Okay, it should be single. Then only they are stable. So, sign of Brownian movement is stability. If your particle is there in Brownian movement, it is stable. Next, diffusion. Diffusion, we calculate the diffusion according to diffusion equation. What is that? Fixed law of diffusion. What is fixed law of diffusion? dm by dt 1 by s is directly proportional to dc by dx. Okay. Diffusion. So by diffusion you can measure its molecular weight. You can measure the molecular weight by diffusion. So there is one equation given. Please tell me, madam, that equation.
D is equals to
RT by 6 pi neta n where?
cube root
4 pi n by 3 m v. You can determine the, see, m is there, molecular weight. You can determine the molecular weight if you calculate diffusion. Diffusion is calculated here. D value is calculated here. This value is substituted here to calculate m value. Simple. So through diffusion you can calculate molecular weight. Through diffusion property of a colloid you can calculate molecular weight. By the diffusion property you can calculate the molecular weight. Okay, tell me this, madam. What is our gas constant? T, absolute temperature. Nu, viscosity. N, Avogadro number. M, molecular weight. V, specific volume. Write down the individuals. Gas constant absolute temperature, viscosity, Avogadro number, molecular weight, specific volume. A B section we have good volume. What happened here? What happened to your specific volume? Why there is specific volume? They should condense. When they are going to condense? Which festival? Okay, next. Viscosity. Shh. Next is viscosity. What is viscosity? That is surface tension. Force per unit length. Resistance to flow. Viscosity is resistance to flow. What we can find from viscosity is, what is the first one, madam?
Shape of dispersed particles.
Shape of the dispersed particle. Okay, wait. Listen. Who has more viscosity? You tell me. Okay.
Watch.
Circle has less viscosity. Elongated shape will have more viscosity. If your colloid is in this shape, obviously its viscosity is more. So you can predict the shape of the particle by knowing the viscosity. By knowing the viscosity, you can predict the shape. What is the next one?
Affinity of particles to the medium.
Okay. I am loving water. Do I have more viscosity or less viscosity? Listen. I am loving water. Means what? I will hold water. I will hold water. So they will allow me to move? No. Resistance to flow, viscosity. So more viscosity. Best example is affinity, lyophilic colloids. Lyophilic colloids have more viscosity. The example itself is gum in water. It has more viscosity. So you can predict the అదేంటే అలా చూస్తున్నాం ఓకే we can predict the viscosity, sorry, affinity of nickel. Okay, affinity of colloid by knowing its viscosity. Remember, lyophobic, less viscosity. Association, less viscosity. Lyophilic, more viscosity. You can know the type of colloid just by seeing the viscosity of colloidal solution. You can know the type of colloid. What is the next one? More affinity, more will be the viscosity. Next is type of colloid. Just now I said. So in the type of colloid, lyophilic colloid has more affinity compared to other thing. Hence it has more viscosity. Next.
Molecular weight of the particles.
Okay, now you tell me. Who has more resistance to flow? A lean guy or fat guy? Fat guy. So molecular weight is more, viscosity is more. Molecular weight is more, viscosity is more. So from viscosity you can predict 1, 2, 3, 4 properties. From viscosity kinetic property you can predict or you can calculate 4 properties of colloids: shape, affinity, type and molecular weight. Then sedimentation. Listen, your colloids are not easily sediment because they are under Brownian movement. How to sediment them? Forcefully, how to sediment them? By using what? Okay, I will give you a hint. If you go to diagnostic center, if you give your blood to to separate your cells and plasma, they use something. What is that? Centrifuge. So that force is not enough. We use ultra centrifuge. We use ultra centrifuge to sediment the colloid. Now tell me who is having more molecular weight. Okay, listen. One is sedimenting at 100 rpm, two is sedimenting at 1000 rpm. Who is having more weight? If that, why? Do you accept? What he said is exactly correct. Low, higher the molecular weight, in low rpm only he will settle. Lower the molecular weight, he required more rpm to settle. Right now, you can calculate the molecular weight by sedimentation. You can calculate the molecular weight by sedimentation. High molecular weight will sediment at low rpm, and low molecular weight particle will sediment at high rpm. So you need high rpm or low rpm for your colloids? High rpm. Colloids are small in size, so you need high. Hence we are using ultra centrifuge. You have to find other method. This is not working out. Okay. What is the next property? Electrical property. What is the first one? Electrophoresis. What is electrophoresis? Is defined as movement of ions under the influence of external electric potential in some liquid. Write down. Electrophoresis is movement of ions under the influence of. Why I am saying ions? Why not I am saying molecules? Only ionized thing will move after applying electricity. Okay, electro. We are applying electricity. So movement of ions under the influence of external electric potential in liquid. If it is gel, what we call it as? Gel electrophoresis. Now, by substituting your colloids to electrophoresis, what will come to know? Good. Charge. Whether the colloid is positive or negative charge. Then next. So your movement is directly proportional to applied potential. If you apply more potential, more fastly they will move. Less potential, less fastly they will move. You got what I am saying? More current, fast they will move. Less current, slow. So remove the proportionality constant. We say we get some constant. What is this? Tipu. What is that? We get zeta potential. This is how you represent. UCN. Zeta potential. How to write it? C. U C zeta potential. Means what? You can also calculate zeta potential as well as charge on the particle by electrophoresis. By electrophoresis, you can calculate charge as well as zeta potential on the particle. ఇది కాదురా, దాంతో తుడిచి దీంతో తుడుస్తుంది అలా. ఓకే, వాట్ ఇస్ ద లాస్ట్ వన్? Donor membrane. Please, very important 5 marks question. Listen to me. First I will tell the concept, then I will tell the what is the equation and derivation. You have stomach. You took some drug in salt form. Drug is in salt form. Drug will ionize into D minus and Na plus. Along with this drug has less absorption property. The drug has less absorption property. I want to increase the absorption of drug from stomach to blood. Absorption was movement of drug from stomach to blood. What I will do is, I will add another thing which is a macromolecule, which is also a salt. It will ionize into R minus and Na. He will be not absorbed because he is macromolecule. He will be not absorbed. But he will increase the absorption of drug. Can you tell why? See the charge.
Same charge they repel.
They will repel. Same charge. What I mean to say is, we have negative charge. Assume these girls are negative charge. Okay. So they are absorbable. They can pass through the door. But I get a huge guy, okay, who can't pass through the door, but he has same charge. Whenever he comes like this, everybody will run. Okay, whenever he comes from there, because he is repelling them, has same charge. So increasing the absorption of your drug by using a macromolecule of same charge is explained by donor membrane equilibrium. Write down that. Increasing the absorption of drug, increasing the absorption of drug by using a macromolecule of same charge, by using a macromolecule of same charge is explained by donor membrane equilibrium. Is explained by donor membrane equilibrium. How, what and why, we'll try to see. How can we do that? We'll try to see by derivation. Please don't write till I finish the derivation. Okay, listen. Don't write, please listen. Inside is stomach. Outside is blood. Inside is stomach, outside is blood. So in the stomach we already have some ions, sodium and chloride. If you give ions in the stomach, they will try to pass through the barrier. and they will attain equilibrium. So if you apply law of Maxwell, inside sodium ion and inside chloride ion is equal to outside sodium ion and outside chloride ion. If I take salt, some salt will be stay in the stomach and some salt will be absorbed in the blood until they attain equilibrium. That's what I represented. Okay. Now I will add in this equilibrium, I will add my macromolecule. So macromolecule is RNA, not that RNA. Okay. Sodium, salt. If I add this, what happens? It will be ionized to R minus, Na plus, and we have Cl minus here. Inside and outside we have Na plus and Cl minus. Now this side negative charge is more, this side negative charge is less. To compensate this, chlorine will move from here to there. To compensate the charge, chlorine will move from here to there, and after some time the charge is compensated. Why negative charge is more here? Obviously he can't move. You can ask me, sir, why R is not moving? R is a macromolecule. He can't move. But the chlorine is moving from here to there. After that, positive charge inside is equal to what? Positive charge, see, the positive and negative are in equilibrium. So positive charge inside is equal to negative charge inside. Whatever the negative charge are there inside. Inside we have two negative charges. Next. Positive charge outside is equal to negative charge outside. What is outside negative charge? Equation 1, 2, 3. Substitute 2 and 3 in 1. Substitute 2 and 3 in 1. Substitute. Wherever Na is there, inside you need to write this. Outside you need to write this. Tell. R minus inside plus Cl minus inside whole. This is substituted here. What is there here? Cl minus inside is equal to Cl minus outside into Cl minus outside. Okay. Now multiply this. Tell R minus inside multiplied by Cl minus inside plus not 2 square Cl minus inside square is equal to Cl minus outside square. I want this Cl minus to come here, to come down. If I send it there, it will be minus. I want it down. So there is a mathematical gimmick. What we'll do is R minus inside divided by Cl minus inside plus 1. Can you accept? I will tell you why. See here. AB plus B square can also be written as A by B plus 1 into B square. Multiply that. Multiply this. So A by B into B square plus B square. Square, this one get cancelled. So AB plus B square. Both are same. Okay. So this is a max trick. That's all. Simple max trick. So I am writing like this. After this also, if you are not understanding, I'll arrange extra classes with, what's her name? Parimala madam. You will get Parimalam there. Okay? You will be changed. Listen. Okay. Is equal to CL minus outside square. Take this down. R minus inside divided by CL minus inside plus 1 is equal to CL minus outside square by CL minus inside square. Take square root at the both side. Hey, R minus is there. Say take square root at the both side. Is equal to square root of CL minus outside divided by CL minus inside whole square. Square get cancelled. Tell me the answer. Square root of R minus inside by CL minus inside plus 1 is equal to CL minus outside by CL minus inside. Now assume CL minus has D minus. Okay. Assume CL minus has D minus. Substitute. Why I am taking D minus? I want to know about the drug, not about the chlorine. I want to know about the drug. So square root of R minus inside by D minus inside plus 1 is equal to D minus outside by D minus inside. Outside is what? Blood. Inside is stomach. I want to increase the absorption. Means outside values should be more. Okay. Now, what I said, you need to take the drug along with R. You need to take the drug along with R, then the drug will absorb. Sir, how much to take? How much to take? This is your Donald membrane equation. Next, we'll see how much to take. Okay, sir, how much? I don't know how much to take. We'll see. If I take the ratio R is to D, macromolecule is to drug. If I take the ratio of 8, if I take it 8 is to 1. 8 molecules of this, 1 molecule of this. So 8 plus 1 is 9. 9 square is 3. 3 is equal to D minus outside by D minus inside. Multiply here. 3 into D minus inside is equal to outside. Outside is what? Blood. Means blood concentration is thrice the stomach concentration. Blood concentration is thrice the stomach concentration. Means what? If you take your macromolecule versus drug ratio in 8 is to 1, the increase in fold will be 3 folds. 3 times. 3 times the absorption will increase. Now I want to increase 10 times. How much I have to take? 10 plus 1 is 11. 10 times I have to increase. See, this value should be 10. What should I take here?
100.
Not 100, 99. So if I take 99 is to 1, so I'll get 100 square, which is 10 times. So 8 is to 1 will be 3 times. 99 is to 1 will be 10 times. That what the Donald membrane equilibrium tells us. Okay. So what it is going to tell? We have time. Wait, I'll explain once again. Listen to this carefully. Inside is your stomach, outside is blood. Give some salt. That salt will be equilibrated between inside and outside. So it is there and it will move here and there. That equilibrium can be written like this: inside salt concentration is equal to outside salt concentration. Name it as equation 1. Next, you give your macromolecule now, which has same ion. Macromolecules has same salt ion. So macromolecule will be ionized. Now what happens? Here the negative charge is more, here the negative charge is less. To compensate, chlorine will move from here to there. Some chlorine molecules will move from here to there. Now we will see charge equivalence. Positive charge is equal to what? Inside. Positive charge is equal to what? Outside. Positive charge inside is equal to negative charge R minus plus Cl minus inside. Positive charge outside is equal to Cl minus outside. Name it as 2 and 3. Substitute.
CN minus is transferred to sodium side.
Cl minus will move from here to there.
Then how you are considering left side?
How? What he is saying is, sir, when you said Cl moved here, Cl should not be there here. How? Why I am saying? మొత్తం వెళ్ళదు, కొంచెమే వెళ్తుంది. Not all will be gone there. Only few molecules will go there. So while I am telling, I tell few molecules of chlorine will go there. Nice question. Substitute. After substituting and doing all this nonsense, you will get an equation. This is your Donan membrane equation. By taking this equation, we will calculate how much amount of macromolecule and drug should be given. In what ratio? Case 1, 8:1 ratio. 8:1 ratio. If I give 8 plus 1, 1 is already here. 8 plus 1 is 9. Square root of 9 is 3. You can increase the absorption by 3 folds if you give in the ratio of 8:1. If you give in the ratio of 99:1, you can increase the absorption by 10 folds. You can increase the absorption by 10 folds. So that what is your Donan membrane equilibrium. Write down.
Take it over. Shakti Sangam, Lakshmi Balaji.